Alright, so in today's video, we'll break down one of the most critical reactions in both general and organic chemistry, oxidation-reduction reactions, or redox reactions. These reactions are fundamental because they involve the transfer of electrons, changing the oxidation states of the molecules involved. We'll cover how to recognize oxidation and reduction, explore oxidizing and reducing agents, and walk through some important examples that apply directly to organic chemistry. By the end, you'll have a solid grasp on how redox reactions are central to molecular transformations. Let's begin with the fundamentals. Oxidation refers to the loss of electrons or an increase in oxidation state, while reduction refers to the gain of electrons or a decrease in oxidation state. For example, in the combustion of methane, carbon is oxidized from BH to She4 to +4 in CO2, and oxygen is reduced from 0 to 2 in H2O. In organic chemistry, oxidation often involves increasing bonds to oxygen or other electronegative atoms, while reduction usually means increasing bonds to hydrogen. To fully understand redox reactions, you need to know how to determine oxidation states. For example, in methane, CH4, carbon has an oxidation state of 4 because each hydrogen is +1. In carbon dioxide, CO2, each oxygen is 2 and carbon is +4. This means carbon has undergone significant oxidation in the transformation from CH4 to CO2. An oxidizing agent is a compound that gains electrons, meaning it's reduced, while facilitating the oxidation of another substance. Good oxidizing agents like oxygen, O2, or potassium permanganate, KMnO4, have a strong affinity for electrons, or are in high oxidation states. For instance, KMnO4 can fully oxidize primary alcohols to carboxylic acids, as shown here. However, using a milder agent like PCC allows the oxidation to stop at the aldehyde stage, preventing further oxidation. Let's explore some common oxidation reactions. In organic chemistry, oxidation often involves an increase in bonds to oxygen or other electronegative atoms. Primary alcohols can be oxidized to aldehydes or carboxylic acids, depending on the oxidizing agent used. Secondary alcohols are oxidized to ketones. Alkenes can be oxidized to epoxides using a peroxy acid like MCPBA. In the case of alkenes, MCPBA oxidizes them into epoxides, which are useful intermediates in organic synthesis. Now, let's talk about reducing agents, compounds that donate electrons. They are oxidized while reducing another molecule. Common reducing agents include lithium aluminum hydride, LiAlH4, sodium borohydride, NaBH4, zinc, Zn. For example, NaBH4 can reduce ketones to secondary alcohols, while LiAlH4 can reduce more resistant groups, like esters and carboxylic acids, to primary alcohols. Here are some typical reduction reactions. Aldehydes are reduced to primary alcohols. Ketones are reduced to secondary alcohols. Carboxylic acids and esters are reduced to primary alcohols using LiAlH4. For instance, when reducing an ester with LiAlH4, you produce 2 alcohols, which is commonly used in synthetic pathways. Let's quickly recap the major points. Oxidation involves an increase in oxidation state, typically by adding bonds to oxygen. Reduction involves a decrease in oxidation state, often through adding bonds to hydrogen. Oxidizing agents, like KMnO4 and PCC, are used to oxidize alcohols and alkenes. Reducing agents, like LiAlH4 and NaBH4, are used to convert carbonyl compounds back into alcohols. Understanding these reactions is key to mastering organic chemistry. If this video helped you understand redox reactions, don't forget to like, share, and subscribe for more. Check out King of the Curve for interactive learning tools that will further boost your organic chemistry skills. Thanks for watching, and good luck with your studies.